So I'm going to do some problems from PP2.2.1. Okay. I'm just going to do numbers 13 through 18, which are the rational functions. I asked you on the homework to just state the domain and range, but this time I'm actually going to graph them, and I feel like that's going to help you out. So let's go ahead and get started. The first problem that we had was number 13. Which was y equals 3 minus 4 minus 2x. Okay, so to find the vertical asymptote, remember always on a rational function, whether we have a constant or a quadratic or square root of a quadratic. Okay, the way that you find vertical asymptote is looking at the denominator, setting that denominator equal to 0. Okay, once we do that, that implies negative 2x equals negative 4. So that implies that x equals, is it 2? And then we see that there's a constant on the top. Okay. Remember, if we have a constant, it could be any kind of a constant, means that it's actually x to the 0, which is 1. Okay, that's what a constant is. Okay, if we have any number in the numerator, or horizontal asymptote, is always going to be y equals 0, because there is no way that that y could turn into a 0 unless that 3 became a 0, and 3 does not equal 0, so therefore y has to equal 0. Remember, okay? So as soon as I do that, as soon as I figure out my asymptotes, I am ready to graph. I'm ready to graph this function. And with asymptotes, graphing becomes so much easier. Okay, so first I'm going to draw my horizontal asymptote. Just like that. And then my vertical asymptote was 2. And I'm going to test some points. How do I test points? I'm going to test points to the left of my vertical asymptote. So x equals 2 to the left of, and a very nice point to test is x equals 0. When I put x equals 0, 3 over 4, it just becomes 3 over 4, which is 0.75. Okay, so 0, and then 0.75, which let's go ahead and draw some of these. 0.75, which is going to be right here. It's actually going to be right there. And then I can put in 1 if I wanted to. Y equals 3 over 4 minus 2, which equals 3 halves. So that's 1.5. 1.5 is going to be somewhere here. And the nice thing about it is that there's an asymptote here, just like that. Just like that. Okay. Now, remember, I said that this right here is x to the 1. And that is an odd function. So odd functions are symmetrical by a rotation of 180 degrees. So if I take this entire graph and rotate it 180 degrees, you'll notice that it's now going to be in this quadrant right here. Okay? So let's go ahead and test some points. The best way to do this is to just test points. So let's find some numbers that are greater than x equals 2. So like x equals 3. y equals 3 over 4 minus 2 times 3. So 3 over 4 minus 6. So 3 over negative 2. So that's going to be negative 1.5. Okay? Negative 1.5 right there. Okay? I could keep on going, but I just really need 1 point. But you're going to get a bunch of decimals. Okay? So there is my equation. If I were asked to write the domain and range of this, domain for rational functions, just pure rational functions without any quadratics or anything in it, is just going to exclude the vertical asymptotes and the horizontal asymptote, such that x is an element of all real numbers and x cannot be 2. Range is going to be y such that y is an element of all real numbers and y cannot be 0. Okay? Good job, guys. Let's do another one. Okay? Number 14 was y equals negative 1 over 3 minus 6x. Okay, so once again, it's a rational function. So the vertical asymptote, we just set that denominator equal to 0. And that is going to be negative 6x equals negative 3. X equals 1/2. Okay. X equals 1/2. And then let's go ahead and find the horizontal asymptote. Once again, we have a constant in the numerator. Okay, so that's automatically tells me that the horizontal asymptote is going to be y equals 0. Okay, let's go ahead and graph that. As soon as you get your asymptotes, I would jump in and graph it. Okay, so we have 1. Make these spaces a little bit bigger. So we have 1/2. I mean 0.5, sorry. As our vertical asymptote. And y equals 0. Okay. Now let's go ahead and test some points. Okay, you see this negative? That means that all of these are going to reflect. So I have a feeling that it's going to be points in these two quadrants right there. Okay, because it's going to reflect. But let's see if our assumption is right. So let's go ahead and put a 0 in. I'm just going to make a table. I like tables. 0 in, and so we get negative 1 over 3. So negative 1/3. 0 and negative 1/3 right there. Use a different color. Okay. So I could try another point. I could probably try negative 1 if I wanted to. Negative 1 over 3 minus 6 times negative 1. Negative 1 over 3 plus 6, which is negative 1 over 9. So negative 1/9 is going to be smaller than negative 1/3. So we have a point right there. It's getting closer and closer to the y equals 0. There we go, there we go, there we go. There we go. Okay, let's try 1. Okay, we're going to try numbers on the right side of that. So negative 1 over 3 minus 6, and negative 1 over negative 3, so that becomes 1/3. 1/3 is going to be like right there. Once again, I just need 1 point. Okay? So let's go ahead and identify the domain. Once again, it's a pure rational function. So it's going to only exclude one point. Real numbers, x cannot be 1/2. The range, y, such that y is an element of all real numbers, y can't be 0. Okay? Good job, guys. Next one, number 15. So we have y equals x minus 2 minus 4x. Okay? Once again, it's a pure rational function. There is nothing funny going on. There is not a quadratic. Okay? It just involves linear functions. Okay? So for these, let's go ahead and set, or even if it involved a quadratic in the denominator, we still set it equal to 0. So we have, for the vertical asymptote, 2 minus 4x equals 0. This implies negative 4x equals negative 2. This implies that x equals 1/2. Okay? We have 1/2 again. And then let's look at the horizontal asymptote. These two had a constant. We had a 3 here, and we had a 1 here, or a negative 1. These have a constant. And so I've asked you to find these algebraically instead of using the trick. Okay, so how do you find it algebraically? Okay, to find the horizontal asymptote, notice that the vertical asymptote, we isolated y. Okay, horizontal asymptote, we're going to isolate x. And this kind of goes to inverse too, when we talk about inverses of these functions. Okay, so I'm going to go ahead and solve for x. It says y times 2 minus 4x equals x. 2y minus 4xy equals x. Let's consolidate the x to one side. So 2y equals x plus 4xy. Let's go ahead and take an x out. We have a 1 plus 4y equals 2y. We're going to divide both sides by 1 plus 4y. 1 plus 4y. So now we have x equals 2y over 1 plus 4y. Now we have isolated the x. Then we set that denominator equal to 0. 1 plus 4y equal to 0. So that is going to be 4y equals negative 1. And so y equals negative 1 over 4. Okay, let's go ahead and graph it. So we have 1, 2, 1, 2, 1, 2, 1, 2. And then we have 1/2. So right here. Negative 1/4. Somewhere here. So, since there was no reflection, I have a feeling that that's where my functions are going to be, or my graphs are going to be. Okay, so let's go ahead and prove that. Okay, let's go ahead and put a 0 in. So we have a 0 over, it's just 0. Anytime you see a 0 over anything, it's just 0. A biome, origin. I draw my first point. And since we're just going to sketch this, there you go. Okay, let's go ahead and put a 1 in there. So 1 over 2 minus 4, 1 over negative 2. Negative 0.5, 1, 0.5, bam! There is that other point right there. Voila! Okay, so the domain of this is only going to exclude, once again, x such that x is an element of all real numbers, x cannot be 1/2, and range equals y such that y is an element of all real numbers, y cannot be 1. Okay? And good job. Next one, number 16. Are you having fun? I'm having fun. Yep. Number 16. Math makes me happy. One minus x, vertical asymptote. 1 minus x equals 0. So therefore 1 equals x. Okay. Next, horizontal asymptote. Let's go ahead and solve it algebraically. Y equals 1 plus x over 1 minus x. So y times 1 minus x equals 1 plus x. Y minus xy equals 1 plus x. Let's go ahead and y minus 1 equals xy plus x. X times y plus 1. Y minus 1. Divide both sides by y plus 1. Y plus 1. So x equals y minus 1. Y plus 1. I got my denominator. Y plus 1 equals 0. This implies that y equals -1. I've got my 2 right here. Nice little integers. 1. Asymptote coming up. And then -1. Asymptote has been served. Okay? Let's go ahead and make my little table. Just like that. Okay, let's put a 0 in there. So 0, 1 plus 0 is 0. No. 1 plus 0 is 0. 1 over 1, so that's just going to be 1. So 0, 1, so there's my point. Once again, it's going to be in these two quadrants right here. I already know this because there was no reflections. Ba-bam. Okay, and I could put in another one. I could put -1 in there if I wanted to. 1 minus 1 is going to be 0. Right there. Just like that. Find some numbers that are greater than the asymptote. So we can do like 2. Go ahead and put 2 in there. Okay, 1 plus 2 is going to be 3. And then 1 minus 2 is going to be -1, which gives me a -3. Okay, and then that is going to be a 2, 1, 2, -3, 1, 2, 3, right here. Hey, that's where my star is. There's another student that likes to wear star stickers on her forehead. She's the most adorable girl ever. Anyways, okay, it's usually this color star. Yeah, okay. There we go. Let's go ahead and identify the domain. Okay, x such that x is an element of all real numbers. X cannot be 1. Range. Y such that y is an element of all real numbers. Y cannot be -1. Ba-bam. Okay? Good job. Okay, number 17. So y equals 1 minus 2x over 1 plus 2x. Vertical asymptote. 1 plus 2x equals 0. This implies 2x equals negative 1, which implies x equals negative 1/2. Okay, let's go ahead and solve for the horizontal asymptote. 1 plus 2x equals 1 minus 2x. Y plus 2xy equals 1 minus 2x. Let's gather the x's on one side. And I'm going to move this y, and I'm going to move this negative 2x to that side. So we get 2xy plus 2x equals 1 minus y. Factor out an x. 2y plus 2 equals 1 minus y. Divide both sides by 2y plus 2. 2y plus 2. So this implies that x equals 1 minus y over 2y plus 2. There is my horizontal asymptote. This implies that y equals negative 1. Right? Okay. Let's go ahead and graph it. Okay, we have a negative 1. I'm going to make those a little bit bigger. So we have negative 1, negative 1/2, sorry. Bam, 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 bam. For my vertical asymptote, for my horizontal asymptote, I have bam, 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 bam. Bam, 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 just like that. Once again, I don't see any kind of reflection being done. I have a feeling that it's going to be right there and right there. But let's go ahead and check x and y. Numbers that are less than, so let's just pick negative 1. So that is going to be 1 minus 2 times negative 1 over 1 plus 2 times negative 1, which equals 1 plus 2 and 1 minus 2. So that's 3 over negative 1. So that's going to be negative 3. Okay, so negative 1. My guess was wrong. And you know why? Chicken thigh. No, I'm just kidding. You know how? Chicken kung pao. Okay, you know why? Do you see this negative right there? So if I rewrite this, this is going to become negative 2x plus 1, right? Right? So if I rewrite this as that and 2x plus 1, it's not the fact that you had a negative in the front. It's the fact that the coefficient in front of that x in the numerator was a negative. Okay? Yeah. So this coefficient is positive. That coefficient, oh, that's the same one. Positive. This is going to be a positive. Okay? And that's why this right here was a negative. It doesn't have a coefficient on the top. Okay? So that's going to be negative 1, 3. Negative 1, 3 right here. Okay? So I can go ahead and graph that. It's just gonna, or I could graph another point. I can put a negative 2 in there. If I put in a negative 2, that's going to be 1 minus 2 times negative 2 over 1 plus 2 to the negative 2, which gives me 1 plus 4 over 1 minus 4, which gives me 5 over negative 3. 5/3 should be 1 and 2/3. So negative 1.7, somewhere around there. So negative 2, 1, 2, negative 1.7, somewhere around there. Oh, that's Leo barking on the outside. Kind of like that. Oh, I hope he's not fighting a dog out there. Okay, so let's go ahead and put it at 0. And then you get 1. And then all of this right here turns into 0 right there. All of this turns into 0. All of that turns into 0. It's just going to be 1 over 1. So 1. So 0 and then 1. Just going to use that 1 point. I'm happy with that because I have the asymptotes to kind of direct where I need to go. There we go. Let's go ahead and find the domain. X such that X cannot be all real. X is all real numbers. X cannot be negative 1/2. Range Y such that Y all real numbers. Y cannot be negative 1. Okay? And good job. Okay, last one that was on there. Number 18, which was Y equals 2x minus 3 over 2 minus 3x. Okay, vertical asymptote, 2 minus 3x equals 0. So that's going to be negative 3x equals negative 2. X equals 2/3. Horizontal asymptote, let's go ahead and solve. X times 2 minus 3x equals 2x minus 3. 2y minus 3xy equals 2x minus 3. Okay, I'm going to move this on this side and that because I don't like negatives. 2y plus 3 equals 2x plus 3xy. X2 plus 3y equals 2y plus 3. Divide both sides by 2 plus 3y. 2 plus 3y. So x equals 2y plus 3. 2 plus 3y. Now I have my denominator. 2 plus 3y equals 0. So we have 3y equals negative 2. That implies that y equals negative 2 over 3. Okay. Okay. Now, let's go and graph it. Let's make these kind of big. Okay, so 2/3 is 0.67, so that's going to be 0.67 right here. Bam, 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 bam. And then negative 0.67, bam, 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 bam. Okay, let's go ahead and make our table. I'm going to put a 0 in there. Okay, 0 minus 3 over 2 minus 0. So that's going to be negative 3/2. Negative 3/2, which is negative 1.5. 0 and then negative 1.5. There is my point right there. kind of like that. Okay, and then let's go ahead and put in a 1. So 2 times 1 minus 3, 2 minus 3. I just saw the same thing, negative 1 over negative 1, which is 1. So 1, 1. There's my other point. There we go. Okay, sorry, I had to stop the video. Okay, so let's go ahead and find the domain. Domain x such that x is element of all real numbers. X cannot be 2/3. Range y such that y is an element of all real numbers. Y cannot be negative 2/3. Voila! And good job, guys.